Hi students, we are going to solve problem number 12. Careful measurement of the electric field at the surface of a black box indicates that the net outward flux through the surface of the box is 8 into 10 power 3 Newton meter square per coulomb. What is the net charge inside the box? This is the subdivision A. The second subdivision afterwards we are going to solve. First we will solve the first part of this problem. So you can assume that this is a box, okay, this is a black box. It is a hollow box which is closed on all the surfaces, and some charge is inside this box. Say it is a Q coulomb, and now the electric field is pointed outwards. Okay, the electric field due to this charge is pointed outwards. So through all the 6 phases, okay, through all the phases, the electric lines of force, are pointed outwards, and the flux is given as 8 into 10 power 3 Newton meter square per coulomb. It is positive. So only for a positive charge, the electric lines of force will be pointed outwards. Suppose if you assume this is a cubical box, for a cube there are 6 surfaces, is it not? 6 faces. So the total surface of the cube is equal to the sum of the area of all the 6 faces. So it is given that the net flux, the total flux is given. So I will take the total flux or the net flux, electric flux, phi is given as 8 into 10 power 3. Okay, so this is 8 into 10 power 3 Newton meter square per coulomb. And since the medium is not given, it is assumed to be air or free space. So for free space, the permittivity, okay, the electric permittivity of a free space, so that is given as epsilon naught. So this is 8.854, okay. So this is a coulomb square per Newton meter square, coulomb square per Newton meter square. So this is a standard value we are supposed to remember. And what is the net charge? So the net charge Q, the net charge Q is asked here. Now just for demonstration purpose, I have shown that the net charge is Q. The net charge is Q. Does it mean it is a single charge? The net charge does not mean that it should be a single charge. It may be a system of so many charges. For example, suppose if there is a charge, 2Q coulomb, okay, and another charge minus 1 coulomb. So net charge means we have to add these two. So 2Q is positive, minus Q is negative. So 2Q minus Q is what? Q only, Q coulomb. So net charge may be what is the algebraic sum of all the positive and negative charges, the total charge, the resultant charge present inside it. So inside the box, we still don't know how many number of charges are present. Only the net charge, okay, we have to find out. So I will take the symbol for the net charge as Q. I want to find out the net charge only. So for this, which law has to be used is Gauss law in electrostatics. So from Gauss law, you can also say that it is Gauss law, okay, Gauss. So from Gauss law, the total flux, the total electric flux of the electric field E, okay. So this is numerically equal to 1 by epsilon naught times the net charge Q. So this is the total flux on the left hand side, that is numerically equal to 1 by epsilon naught times the net charge which is on the right hand side. So from this equation we have to find the value of Q, okay. So here Q is equal to, okay, therefore Q is equal to 5 multiplied by epsilon naught. So we have to multiply the value of 5. 8 into 10 power 3. So this is 8 into 10 power 3 multiplied by 8.854. Okay, 8.854 into 10 to the power of this is minus 12, is it not? Here into 10 power minus 12. So only the numerical value I have written. Now I will take so into 10 to the power of minus 12. So this is a Coulomb square per Newton meter square. So I will write into 10 power minus 12 also. Okay. So I want to multiply these two numbers. So if you multiply means 8 into 8.54. 8 into 8.54 is found to be 70.832 into 10 power minus 12 multiplied by 10 power 3 is how much? 10 power minus 9. So into 10 power minus 9. So 10 power minus 9 and the unit is Coulomb. 10 power minus 9 Coulomb is nano Coulomb. But normally we express it micro Coulomb. So that is 10 power minus 6 I am going to express. Therefore I am going to adjust the decimal places. So this is also written as 0.070832 into 10 power minus 6 Coulomb. So the last 3 digits I am going to eliminate. I am going to round it off. Okay. Therefore the net charge Q is equal to 0.07 into 10 power minus 6 Coulomb is also equal to what? Micro Coulomb. So this is the answer for the first part of this problem. So for the first part of this problem, what is asked here? What is the net charge inside the box? So my dear students, I am repeatedly telling you that this is the net charge. It may be the resultant of 2 or more number of charges also. Understand? So 0.07 microcoulomb of positive charge. Positive charge is present inside the box. Okay, now let us read out the second part. If the net outward flux through the surface of the box were 0, that means what? If flux is equal to 0. So in this case, if flux is equal to 0, right side also should be 0 or not? Then only it is possible. So if flux phi is equal to 0, the net charge, okay, the net charge also must be equal to 0. Have you understood? Okay, I will read once again. If the net outward flux through the surface of the box were 0, could you conclude that there were no charges in the box? Do you mean that there is no charge inside this box? Say for example, I will take a box, okay, I will take a box and inside there is no charge. When there is no charge, what will be the flux coming out of the box? 0. If Q equal to 0, definitely 100% we can say that the flux phi also is equal to 0. But does it mean always? Say for example, I will take a plus 5 coulomb, one charge is kept inside, and minus 3 coulomb, minus 2 coulomb. How many charges are present inside this box? You tell me now. Number of charges, 3 are there. The first charge is plus 5 coulomb, second charge is minus 3 coulomb, and third charge is minus 2 coulomb. So 3 charges are physically present inside the container. But what is the net charge? Net charge 5 minus 3 minus 2, 0 coulomb. Is it not? So in this case also the net charge is 0, but the individual charges are not 0. That is the question here. So if the net flux is equal to 0, means net charge only is equal to 0. Understand? So net charge is equal to 0 means we cannot say that there is no charges present inside the container. Charges may be present, and the algebraic sum of the charges only is equal to 0. That is why the second part for understanding level question. Could you conclude that there were no charges? No, we cannot conclude. Why or why not? Why or why not? Why we cannot conclude? Because when there is no charge inside the box also, the net charge is 0, flux is 0. But when there are so many number of charges kept inside the container and the addition or the net charge, okay, that is the algebraic sum of the positive and negative charges also may be equal to 0. So we cannot conclude that there are no charges inside. It depends upon the sign or polarity of the charges also. So the net charge present inside this given container is 0.07 microcoulomb, and the net charge may be the algebraic sum of the given charges. So the flux will be 0 even when charges are present inside the box also. It is possible. I hope you must have understood well. Fine.